Hello, people. So far, I've done 4 video segments on composites. The first one was basic comments about why is it that you don't find uh, free learning resources on internet for doing composites and analyzing it using its native finite element analysis. Then in video segments 2, 3, and 4, I made 3 problems, and they involve with different scenarios that you can combine in a very simple problem. However, the stacking sequence or the stack was the same. There was a single region, a rectangular region, which had a given stack of laminas on it. What I want to do now is make it one notch more complicated so that you actually have uh, again the same rectangular, very simple geometry, rectangular strip. One end is clamped, the other end is subjected to an in-plane load given here. But this composite is made of 2 laminates. One of them, which is 50 millimeter by 50 millimeter, has 2 plies on it, 0 and 45 degrees in that order from the top all the way up. And then the second one, which is the rectangular piece, has three plies, 3 laminas, 90 degrees and 2 0 degrees. Of course, it is true that one can combine these two and use a single laminate of a double the thickness. But I'm gonna use exactly the way it is. Okay. Now, let's see. I was gonna say, yeah. So, we are assuming that this laminar, this composite is made of Kevlar, and the material properties are given from are taken from the CATIA v5 default database. Okay, so let's go ahead and do that. By the way, because I have 2 stacks, 2 laminates here, I'm going to create my region so that it's 2 surfaces. One is the square piece that you see here, and then the other one is the 100 the rectangular one. Okay, so let's go ahead. All right. On a convenient plane, on that horizontal plane, I will sketch. I'll make sure, first of all, you're in generative shape design. Okay. On a convenient plane, that horizontal plane, I will sketch a rectangle like that, 50 millimeter by 50 millimeter. I'm going to make this thing 50 millimeter by 50 millimeter, 50 millimeter. Okay. And then while I'm here, let me actually go change my units so that I don't have to type millimeter all the time. Tools, options, tools, options. Uh, Length is in millimeter. Let's go here and get the stress, force in Newton, okay, and stress or pressure in, I'll put down MPa, megapascal here. MPa right there. Okay, good. Okay, so exit. Now, why don't I call this thing the square piece, the square 50 by 50? How about that? So I'm going to change the name of this, although it's not necessary, but 50 by 50. Okay, so we say all right, and let's do another one on the same plane, XY plane. I will sketch another rectangle. This time it is going to be Uh, well, first of all, let's clean this up. This this dimension is going to be 50, 50. Okay, let me make these two coincident with each other. This control that, make it coincident so that they touch. Oh yeah, this is not I have to delete this. If I make this and that coincident, then this dimension becomes redundant. So let me delete that. That point control this point coincident. Okay, very good. And then obviously it makes this thing 50 millimeters and this dimension 100 millimeter. 100 millimeter. Exit. Okay, so let me call this thing 50 by 100. 50 properties, 50 by 100. Say okay. Very good. Let's save this thing. File. File. What is that? File. Save management. It's already in the right folder. Save. Okay. Okay. Now we're going to put surfaces through these two different sketches. So here is a fill. See that? Fill. Fill. I'm going to fill this one. Say okay. And immediately I'm going to join it. Okay. So join. And just so that I remember, maybe I should rename this thing properties 50 by 50, 50 by 50. Okay. And based on the stuff that we have done before, when you join, you get an orientation. I'm going to flip the orientation so that the orientation of join is down. And because of that, every time I create a mesh, a shell mesh up here, it's normal direction, normal, the third direction to the shell is going to be up, opposite the joint. Okay, good. So now we're going to fill the other guy and join it. And I'm going to call this thing right-click properties 50 by 100 by 100. Okay. Let's make sure that the direction is down, just like the other one. Okay, we save everything. And I can create a rosette right now, but on purpose, I'm going to wait until later on to do the rosette for you. You can create it at this point with the, where is that thing, coordinate system? Where is my, uh, yeah, my coordinate system, I probably closed that, but that's okay. You know, I'll show you that we can do that later on. Otherwise, I have to reset my toolbars and things like that, or I have to go and do it from up here. I'm too lazy to do that, so just leave it the way it is. Okay, so we now go to mechanical design and uh, composite design. Okay, notice that we have access to creating coordinate system right up here, right? Okay, that's why it was not necessary to go and reset my toolbars there. Okay, so first of all, the composite parameters. We're going to add a material, and we'll use the database, Catia database. So default database. So composite and that and Kevlar is Kevlar 4, and there we are. Okay, now if I know the thickness of the lamina, then I have to put it in there. But I use the default thickness, which I think was 0.2 millimeters. Well, I didn't change it. Default values. Okay, good. Now we're gonna start. Okay, I will now select the rosette tab here, and the rosette tab, and for the rosette tab, I don't have one. Okay, you see, I don't have one. So I said add a rosette. Okay, so this dialog box opens up and gives you the opportunity to pick it. So for access system, we don't have one, so we're going to create it, okay, which is right here. And then let me move this thing a little bit to the left so that I can actually uh, see it better. So create a point. Yeah, that's good. So it's going to put it there. You say okay. Remember, this is the newer versions of Catia, last 4 or 5 years, 6 years. So this is the rosette, so I'm going to hide it, okay? And we say okay, and all right, okay. Say okay. Now there is something called laminate here, but I'm not going to use it because I'm doing this manually. So, but it is very important. We're going to talk about later on. If the thickness of your acute thickness the cured thickness of your laminate is different. Right now it's 0.2 millimeter. Then you can change it, but I'm going to leave it use the default. Okay, good. Or you may have to use your own material properties. Okay, so that's good. Now we're going to create a ply group. Well, I'm going to create two ply groups. One of them for the stack on the square piece, and the second plies group for the stack on the rectangular piece. Okay, selection is this square. Flip it up so that my direction of my draping is cleared, and lock the plies direction. And then for rosette, I'm going to choose rosette 1. And that's it. Okay, notice that one plies group is created here. I can do the other one, or I can do it later. So the other one is this surface. Flip it up. And rosette is rosette 1. And we say again, lock the direction. So we say this. Now we're going to create our stack. Okay, so here it is, ply, see, ply. It says, where do you want to put it? Well, I want to put it in plies group 1, right there. See at the bottom left corner, you see it's asking you for which group you want to put in there, group 1. Okay. So for geometry, it says the contour of these plies in group 1 that you're trying to create is not defined. Do it. So I'm going to select this first sketch. See that? Remember, I did a sketch like that, and I also renamed it, but that's okay. So 50 by 50. Remember, I renamed it. And the attributes is based on my slide here, 0 and 90 in that order. So the first one is 0 and Kevlar, very good. Okay, another one, group 1, again same contour, and 90. Say okay. That takes care of the two plies that I want to put in here. Okay, sequence. Incidentally, I did not have to actually create individual sequences. I could have put this ply 2 in that sequence. There is no reason to say that, oh, sequence basically defines the manufacturing process. It may be associated with the manufacturing process. I can put both of these plies in the same sequence. There is no problem. As a matter of fact, you know what? What I'm going to do is on the next one, I will create only one sequence and put the plies, which there are 4 of them, in there. Okay, so let's do it again. Ply, group 2. For the ply 3, so I select this other rectangular boundary right there, sketch. And this is going to be, which one? First one is 90. If you look at my transparency, this is 90. Okay, very good. And we say okay. Now, there we are, and there we are. For the next one, next ply, instead of selecting the group, I'm going to select that sequence. So what's going to happen, the next ply that's going to create, puts in that sequence. It doesn't matter, okay? Right there. So for curve, that curve, and if you look at the drawing, the slide, this was 0, and the next one was also 0. Next one, in that sequence, this sketch, sketch, and the other one was also, oh, the other one was not 0. That's correct. But one mistake that I made is that this ply number 2 actually should have been 45 degrees. So if you double click on it, this should have been 45 degrees, not 90. That was my mistake. Good. So we're pretty much done here. So let's save everything. All right. Now let's go ahead. We're done here. So we go to analysis and simulation, advanced meshing tools. Say OK. We're going to create a nice rectangular mesh there. So you click on the surface mesher, you select that. Remember, the direction is up. That means that the normal to the shell elements are pointing up. Now, look what's happening here. I said automatic mesh capture, okay? Automatic mesh capture. If you don't use this thing, it will create a bunch of nodes on the right side of this line, and when you mesh the other rectangle, it's gonna create a bunch of nodes on the left side of that line, and these nodes are not the same. I'm not going to do it in the present tutorial. I'll do it in the next one. I will uncheck that and show you what happens if you do this. But notice that I said automatic mesh capture. In other words, every time you see two nodes within 1 millimeter of each other, merge them. That's what it means. Okay. Parabolic, quad, say OK, and mesh it or zap it. Let me say OK and exit. This is meshed 10 millimeter by 10 millimeter. I think that's what it was. Is it? Was it 10 millimeter? I can't remember. Oh, no, 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 10 millimeter. 10 millimeter. 10 millimeter. Okay. And it tells you that, oh, I'm going to change the mesh. We say fine, do it, and then zap it and exit. Okay. Now let's do the other side. The other side. So once again, surface mesher. On this side, a 10 millimeter stays, automatic mesh capture. Say OK, zap it, and we say OK and exit. All right, so let's go ahead and let's go to generative structure analysis. If you want to see your mesh, right click mesh visualization, change the rendering to third one. Now if you put the cursor, 1, 2, 3, 4, 5, so this is where the line is. So if you put the cursor here, notice that that element shows you node 31 on this side, and the other side shows you node 31 too. If I had not merged those things, if I uncheck the automatic mesh capture, these nodes will be different. Later on, when run at the Catia will bomb out. Watch the next video segment. We're done here. Okay, let's us do a couple of things. First of all, you realize that uh, okay, you realize that when I did this thing, if we go here, I will run this thing and then I will come back and make some changes. Okay, yeah. All right. So you might say, well, what is that cut and paste that you have in the title of the presentation? Well, we're going to come back and use that later. So first thing we're going to do is we're going to hide the stacking sequence, stacking engineering, hide it, because I don't want to pick the edge of a ply here later on, and I'm gonna hide these two sketches also. So we have two sketches here, two sketches. Hide this and hide that, because I don't want to put the restraint on the. I mean, you won't let me put it on the edge of the sketch. Okay, so what do we have? We have this end is clamped. This end is clamped. Okay. and this is subjected to a load 10. This is subjected to a load 10 Newton per millimeter. Okay, so we put down 10 Newton per millimeter, which automatically converts it to 10 Newton per meter, or 10,000 Newton per meter. We say okay. All right. Now we have to import the composite property. Import the composite properties. The support. Let's start with this side, with this stack, and it's going to be by plies, and then we're going to select the plies. That's going to be ply group 1. So we have to be able, we go to this, expand the tree, we go to our stacking branch and ply group 1, okay? So ply group 1, say okay. And, but we don't want it to be symmetric, we want it stacked up like, that. What this symmetrical means, I suggest you look at the previous video segments, because if you check that thing, means that that stack that you created is going to be symmetrically located above and below that first plane, okay, first surface, which means it's going to be 45 above and 0 below, okay, but that's not what I want. Then we're going to import the other one. For that, uncheck this, plies, uh, plies group 1, plies group 2, sorry. We say OK, and we say OK. All right, so save everything, file, save management. I hope that I didn't forget anything. Yeah, so we go file, save management, save as. This analysis is we're going to put in the same folder. Desktop. Where is this basic stuff? Okay, and all right. Okay, so let's run it. And it is done. So let's look at the deformation, displacement, right there. Change the rendering, average ISO, material shading. There we are. Now, uh, these the thickness of this ply was 0.2 millimeter, and the load that we put it probably is too large. So you can see that this is not a realistic number, okay, 95 millimeters. So what we can do is we can go and change the load there. That you see that 10,000 pound per Newton per meter means a ton per meter. So that's ridiculous. So let me go ahead to my load here. Load, where is it? Load. Let me knock off 2 of these. So that's 10 meter, almost 10 meter, 10 kilogram force per meter. So that's more realistic probably. It's going to be 100 times smaller, which is more meaningful. Run it. Okay, so displacement, activate. There we are. And if you scale it, it looks like that. That means the thing is going to go up by, and of course probably stretch and shear and things like that, by almost 1 millimeter. Okay, now, why did I call this video segment uh, uh, cut and paste? So let's say, first of all, we deactivate this. Let's say that you actually wanted to make some changes to your to your composite. So we go to back to composite. Actually, maybe I double click on this thing, it'll take me there, right there. Okay, right there. Okay, so if you look at your stacking sequence, it was like that. Let's say I want to add two more layers, two more plies to, let's say I wanted to add two more plies to group one, okay? Both of them being at minus 40, well, actually, let's make it a 90, first 90, and then minus 45. So what I can do is I can copy this, copy, and paste it. You can do it in the same sequence, or you can do it up here. If you do it up here, then it's going to create a sequence 3, okay? So let me do that. Otherwise, you just put it in sequence 1, okay? Paste. Did it do it? So let me try that. Let's try it again. Copy. I don't think you can paste it here. Maybe you have to paste in the sequence. If I had done the copy the sequence, probably would have been okay. Right, okay. And do another one. Do another one in the sequence. Right click, place. So basically, I have repeated this thing, copied this thing twice. So right now, the names are the same. The orientation is whatever we had up there, etc. So let's change these. Double click on that. First of all, the name, I don't want to call it ply 1. I'll call it, I don't know, ply, I'll call it ply 6. How about that? Ply 6. And then the attribute is not, this is not 0 because I copied that. So I said that suppose this is 90 and do the same thing here. Uh, Double click on this and the attribute is, I'm sorry, where was it here? Oh, this ply 2, this is the one that I wanted. Ply 2, I'm going to call it ply 7, right? 7. And the attribute material, the angle is 45, okay? So I did 90 and another 45, okay? I don't know, maybe I said minus 45, so that's okay. You can go and change this into minus 45. Okay, good. Why don't we check this thing? Check this thing. So we can stack these up on top of each other right there, right there. Apply group 1, I made a change here, and then we say apply. Okay, the reason nothing shows up is because my stacking sequence, I hid it, so hide and show right there. And let me actually change this thing to 50 so that we can see it better. Place group 2. Oh, not this, sorry. Place group 1, that's what I wanted. Yeah, apply. Okay, why am I showing only, let's try this. Oh, there we are. Okay. I didn't want that. I wanted this guy. So notice that originally I had 0 and uh, and originally I had 0 and 45, but then I added some stuff. However, these are not correct. So it should go like this: 0, 45, and then the two that I added, 0, 90. So let's go and check these. Check these. So this one, this one was number 6. That one I wanted 45. That's what it was originally. Okay. And this one was minus 45, and this was 90. Okay. So this is 90. So it's always a good idea to check these things. Good. 0, 45, minus 45, and 90. Okay. And now we're going to also look at, let me get rid of this stack. So let me get rid of that. Actually, I can do another one. group two, and then apply with this, apply. So this is what I had originally, 9000, okay? And I wanted to, let's say I want to add, let's say I want to take, I want to add two more to this, okay? So what I can do is right click, copy, and in the same sequence, right click, paste, and another one, copy, and another paste, paste, okay? So now go change these things. So I don't know, what did I call this thing? Call this thing maybe number 14. And I added one that is 45. Okay, and this one I'm going to call it 15, 15, and I add minus 45. Okay, so you know what? Let's plot these things. Actually, let's get rid of all of these. The fastest way is to put the cursor there, right click, and then all the way to the down, say delete exploded surface. Gone. So we go back here to the ply exploder. Ply group 1 is going to be just like I did before. There we are. And ply group 2 is selected plies group. But let's look at the value that I get. So right click, activate. So I'm not sure. No, I think it did change it actually. It did change it, and we can make sure we double. Okay, so let's go ahead and plot the stresses. So put the cursor right there. Image, generate image to the image. So stress, show me the stress. Nodal values. Okay, so double click on this in the global direction, make more global. Okay, and what do we want? So for example, this is C11 in different layers. So notice that we have several laminas, okay, and but it's it's easier to do it through this. These are different plies, okay. Remember, these are the ones that I created. For example, in that last ply that I added, this is the value of the stress in the fiber direction, okay. If you do von Mises, this is the von Mises stress, okay. You can plot it. Von Mises stress would not let you choose coordinate system. It's always global. So, but you can look at the different, but if you look at the different laminas, lamina 6, lamina 1, etc. So these are the different laminas. Okay, so there will be a second part of this, but for a different model. Okay, good luck. Or maybe I should summarize what we did here. Okay, so we go back. The idea was I created some plies manually, but then for later on, or even at the time that I created there, I could have created one and then cut and paste, okay? And then I had to go and change each one of those. I had to go and change the particular orientation or a particular material if it was changing. This is not practical when you have a lot of plies or, so maybe there may be an easier way of doing it, and this is what we're going to do next.